atomic theory. And there's 5 steps to this, and here's what Dalton proposed. He said all matter is composed of extremely small particles called atoms. And in the second step, he said these atoms are in elements, and they're identical in size, mass, and other properties, and atoms of different elements differ in size, mass, and other properties. The third thing he said is these atoms cannot be subdivided, created, or destroyed. Also, these atoms of different elements, they combine in simple whole number ratios to form chemical compounds. And in chemical reactions, these atoms are combined, separated, and rearranged. And out of this atomic theory, we got 3 laws. And the first of those laws is, technical difficulty here. Okay, the first law we have is conservation of mass, and it states that mass is neither created nor destroyed during ordinary chemical reactions or physical changes. Well, an example of this is during, like, you have a big old block of ice, and you take the mass of the ice, and even after the ice melts, it's still going to have the same mass even when it turns to water. Okay, so the second law we have is the law of definite proportions. And the law of definite proportions is the fact that a chemical compound contains the same elements in exactly the same proportions by mass, regardless of the size of the sample source of the compound. So an example we have here is the compound of water, which is made up of 11% hydrogen and 89% oxygen. And you have to get these same exact proportions to get water. Even if the ratios were slightly off, then you wouldn't get water. You would get a totally different compound. The third law we got was the law of multiple proportions. And it states if 2 or more different compounds are composed of the same 2 elements, then the ratio of the masses of the second element combined with a certain mass of the first element are always a ratio of small whole numbers. An example of this is you have the elements carbon and oxygen. And in the elements carbon and oxygen, they combine to create what we know as carbon monoxide and carbon dioxide. Well, in order to get carbon dioxide, you need 2.66 grams of oxygen to combine with a constant of 1 gram of carbon. Well, in order to get carbon monoxide, you have to have 1.33 grams of oxygen, and that combines with 1 gram of carbon to create carbon monoxide. Well, when you take the 2.66 needed to make carbon dioxide, the 2.66 grams of oxygen that is, and you divide it with the 1.33 grams of oxygen and carbon monoxide, and you divide these two together, you get a number right around 2. And that's a small whole ratio, and you take the 1 gram of carbon that you had to make these 2 compounds, then you get a small ratio of 2 to 1, which is basically what the law of multiple proportions states. Now let's move on to the timeline. So, here, bring up the timeline. There you go.
Did you pause it?
It doesn't pause.